Hi guys, this is the video tutorial for Skill Worksheet number 3, which is titled Adding Fractions with Unlike Denominators. Now, we've been working with adding and subtracting fractions in class, and one thing that we're quickly discovering is that before you can add or subtract two fractions, you need to have a common denominator. In other words, we need to be making these fractional parts that we're dealing with out of the same amount, or in other words, the same size. Before you put things together, you want to be putting together the same type of thing. In other words, we don't want to put halves with eighths, we want to put eighths with eighths. Which leads me into the very first problem on the entire sheet, which says this. Now, the one thing I'm going to warn you about is this sheet is not put together very well. What I'm getting at is they give you the problem stacked vertically like this. Now, recall two things. First of all, yeah, we usually add vertically, but it's better to rewrite fractional addition problems horizontally. That way we can compare them this way. And the other thing is this. You don't add fractions straight across. You just don't do that. This is not 4/10 as my answer. What we need to do is make these things the same denominator. Here's the reasoning behind this. Recall that 1/2 could be drawn like this, and 3 out of 8, well, 8 equal pieces, 3 shaded in. If we put those together, honestly, we have this 1/2 plus these 3 more 8s. Question is, what does that all put together? Well, I can't tell you because these aren't the same size. So what could we do? Well, let's make them the same size. Now, recall, it's easier to take bigger things and split them up into smaller things. So what I'm referring to is this half right here. Could I make it be out of 8 pieces? And the answer is yes. Hey, let's take this half and split it in half. Now I have fourths, and split those fourths in half. Now it's easy to see, out of 8 here, there are 4 shaded in. Now recall, 4/8 is the same as 1/2, and we know this mathematically because, well, 2 times 4 equals 8, and 1 times 4 is 4. So 4/8, and now it becomes 4/8 plus 3/8, and we have a common denominator. It's very easy at this point to state that there would be out of 8, 7 total pieces shaded in. And just to verify this, we can split this solution that we had before up into those 8 pieces. So we do have 7/8. And this answer is already simplified. The key here is that we're finding a common denominator, and when you add two fractions, that denominator stays the same throughout. Even on your answer, you're going to have 8s. So if you put 8s with 8s, you're going to have 8s. You're not going to have 16ths. Okay? Now I look down at number 20. It's kind of hiding down here at the bottom of the page. And remember, they give it to you stacked like this. You're going to want to rewrite it horizontally. I look at this, though, and I say, without even drawing a picture, I'm not necessarily going to be having a very good time trying to put 9ths with 6ths. Okay, so I'd like them to be the same size geometrically. So I look at this, I say, well, hey, what could I turn 9 into that I could also turn 6 into using multiplication? And one very simple solution that we're starting to discover is this. We can just take these two numbers times each other, and that would present a common multiple between 9 and 6. So instead of having to list out all the multiples of 9, 9, 18, 27, 36, 45, 54, okay, we can just go and say, well, 9 times 6 is 54. Now here's the neat thing about this. I'll just go ahead and take this times 6 to turn it into 54, but if you take the bottom times 6, you got to take the top times 6. Okay? Same thing over here, except we'll take 6 times 9. That'll turn it into 54. We'll take the top times 9 as well. In other words, if you're starting to notice a pattern, awesome, here's the pattern. We're just taking this fraction times this guy's denominator, and we're taking this fraction times his denominator, and then we have a common denominator. Now looking at this, I know we're going to have 54ths. You know why I know this? Because I made that happen. Okay? I even know that when I put 54ths with 54ths, I'm going to have 54ths on my answer. Woohoo! Okay? Here's the question. What was 1 times 6? We had 6 of these 54ths, and over here we had, well, 5 times 9 is 45. Plus 45 more 54ths. So 45 plus 6, so 46, 47, 48, 49, 50, 51. We have a total of 51 54ths. Now, I wouldn't expect many people to know this, but actually 3 divides into both of these. Bottom line is this. This is the correct answer. We do need to reduce it. I recognize, because I'm kind of a geek, that 3 goes into both of these, but I would divide them both by 3. So divide by 3. Sorry here, I'm kind of writing down at the bottom, sideways. And I know 3 goes into 51 17 times because I'm a geek like that. And I know 3 goes into 54 18 times. So properly, we should be listing as our final solution 17/18 because it's in reduced form, simplest form. But 51/54, hey, if you can give me that, what that says to me is you actually know what you're doing. You know how to add two fractions together by finding a common denominator, keeping your denominator the same to your answer, and operating on the numerators. Hope that helps you with the homework.